So now let's look at the inverse trig functions. So I don't want to spend too much time on these, but there are a couple little small things that I do want you to know. We've talked about inverses a lot in this class, so I'm not going to take too much time here, but remember that a function f of x has an inverse if it's 1 to 1. Okay, so remember that f of x, a function f of x, will have an inverse as long as f of x is 1 to 1. Okay, and remember that in order for it to do that, it needs to pass the horizontal line test. So when you think of sine and cosine, those guys are not going to pass the horizontal line test, right? So if you look at cosine, this guy is not going to pass the horizontal line test because it's too many. For every x value you have, for every x value, there's too many y values. Okay, so there you can't. It fails it. Same thing with cosine. But one of the things that we can do is we can restrict it. So let's just go ahead and first define f in sine inverse, what it actually looks like. So if f of x is equal to sine of x, then the inverse would be f inverse of x. Okay, which is how we would say it, sine inverse of x, not sine to the -1. That's something very differently. Now, sometimes what you'll see is also call it arc sine. That's just another way to think about it. And actually, arcs makes a little more sense because a trig function, for example, sine of x, the input is the measure of the angle and the output is the ratio between the two angles. Whereas the sine inverse, you input the ratio and you end up getting the measure of the angle. And you remember, a radian is the arc length, right? So it makes sense why we would call it arc sine instead of sine inverse. So you can choose sine inverse or arc sine, whatever you'd like, right? And also there's arc cosine and arc tangent. So this is kind of what we want. We want, for example, sine pi over 6 equals 1/2. So that means that pi over 6, the angle, is equal to sine inverse of 1/2. Okay, so this is kind of the opposite. Same thing, cosine of pi equals -1. So that means pi is equal to the cosine inverse of -1, and so on and so forth. Now, what's going to happen is that, and this you must have done in your trig class a lot extensively, is that what we're doing is we're going to restrict the sine curve. So we know that the sine curve looks something like this. And what we're going to do is we're going to pick a portion of the sine curve that will satisfy the horizontal line test. So we're choosing this guy. That's why the sine curve looks something like this. So we're only choosing this guy, and we're restricting the domain to be from -pi/2 to pi/2, and the range to be -1 to 1. That way, it can be an inverse can be found. And when we interchange all the x and the y values, you actually get the arc sine function or the sine inverse function. So you can see that the domain and the range are swapped. Same thing can happen with the cosine curve. We actually picked this part, so the one in quadrant 1 and in quadrant 4. Okay, so we ended up picking, not quadrant 1 and quadrant 4, quadrant 1 and quadrant 2. So we ended up picking this part of the cosine curve, right? I could have chosen anything that I wanted, and you ended up getting this arc cosine curve. Same thing with the tangent curve. Tangent looks like a piece of spaghetti, like the x cubic. I'm only going to pick that one portion. You can see that it kind of looks like the cubed root here. All right. So again, I'm switching the domain and the range here. Okay. So I'm cutting these guys so that I make them a lot easier to work with because we know that it's not going to be 1 to 1. Now, if I'm restricting the sine curve, for example, to the arc sine, what I'm really doing is if you look at the domain, -pi/2 to pi/2, I'm only looking at, here's -pi/2 and pi/2. I'm only looking at quadrant 1 and quadrant 4. Okay? So I'm only looking at these two different quadrants. So whenever I use the arc sine, I can only get values from quadrant 1 and quadrant 4. Those are the only values that I can get, okay? I can't get them from quadrant 3 or quadrant 2 because that's not where I restricted this domain. Same thing with arc cosine. All of my values are going to be restricted from 0 to pi. Same thing with tangent inverse. Tangent is only going to be from negative pi over 2 to pi over 2. Okay? All right. So technically, because of these restrictions, you're not including the other values. So your calculator, so if you go to your calculator, especially if you have the TI-36X Pro, and you set it into radians mode, and you put sine inverse. Well, you're going to see sine, and then you'll see sine inverse. So in order for you to activate the sine inverse, just press button twice. So you're going to press the button twice, and that's how you're going to get the sine inverse. So, for example, let's say you wanted to find the sine inverse of, I don't know, 1/2. Okay, so you can go ahead and put that in your calculator, sine inverse. You can put 1/2, and make sure that your mode is in radian mode. So when you do that, what you're gonna end up getting is pi over 6. Why pi over 6? Well, think about it. Here we want to figure out where exactly is the sine equal to 1/2. Well, the sine is equal to 1/2 at 30 degrees, right? Which is equal to pi over 6. But notice that this guy is also going to be equal to pi over 6 over here at 5 pi over 6. Because at 5 pi over 6, I also have square root of 3 over 2. 1/2, with this one being negative. So you actually have two angles. There's actually two solutions to this answer. There's two angles in which the sine inverse is 1/2. However, the calculator is only going to give you one solution, which is going to be the pi over 6 because of this restriction. Okay. So later on when we solve equations, we will have to do some other things because our calculator will only give us only one solution. Okay. So just keep that in mind, the restrictions. All right. So this is just talking about the arc cosine. Or arc sine, why they call them arc. And then the next thing that you're gonna see is kind of like a little more information. This is more of an FYI. Tells you a little bit more about how we constructed the sine curve. So this is more of an FYI. So for your information. The only thing that you really need to know is the domain and the range. That's really what I really care about. That the domain is -1 to 1, and the range is from negative pi over 2 to pi over 2. Okay, so we're only looking at that guy. All right, so let's just remind ourselves. Domain and range. So the domain is only from -1 to 1. And the range will be from negative pi over 2 to pi over 2. This is for the sine inverse. Okay? So now one of the things that you can do is you can use your calculator if you want to. Some of them you won't be able to use your calculator very easily, but we're going to do it first by hand, but of course you can use your calculator. So let's take the sine inverse of 1. All right? So what we're looking at, if we look at sine inverse, remember we're only looking from negative pi over 2 to pi over 2. Where exactly is a sine inverse 1? Well, isn't that just going to be over here? If you look at the unit circle, 0, 1, the y value here is 1. So the angle that corresponds with that is pi over 2. So this guy will just be equal to pi over 2. Okay, you can see that that one is within the range. So you're still good. Now let's look at sine inverse of square root of 2 over 2. Again, you can use your calculator if you want. All right, so sine inverse of square root of 2 over 2. But one thing that I want is exact answers. So if you put it in the calculator, make sure that it gives you the exact answer. All right, so this guy, we're going to look at square root of 2 over 2. So if you look at the unit circle, the only point where this is the square root of 2 over 2 would be at pi over 4. Pi over 4 lies within this range, so this answer would be pi over 4. Just by looking at it. So again, sine inverse just tells me what is the angle? What angle gives me this value? All right, sine inverse of -1/2. All right, so if you look at, you remember your unit circle, so have your unit circle handy with you. Again, we're only looking at these two regions. Negative 1/2 is going to be down here. Okay, so this guy, square root of 3 over 2, negative 1/2. Now, if you look at your unit circle, this is going to give you something that is past the range of negative pi over 2 and pi over 2. Okay, so I think it's going to be like something completely different that we do not want, okay, which is going to be like 11 pi over 6. That's not the correct answer. Okay, so what would be the correct answer? So my correct answer in this case would be, well, if I know that this is positive pi over 6, then if I go the other direction, this is going to be negative pi over 6. So this guy's going to be negative pi over 6. All right, let's take a look at this guy. Sine inverse of 1/3. Well, I don't know quite what sine inverse of 1/3 is, right? But notice that 1/3 here is within this restriction. Okay, so we can actually restrict it. The domain, right? A 1/3 is in between sine, between negative 1 and 1. So, and notice when you have sine and sine inverse, in this case, this is going to cancel each other out because 1/3 is within the restriction. So we can cancel these guys out, and I'm just going to get 1/3 because it's kind of like undoing it. All right, now let's look at this guy. This guy, we cannot break them apart because remember, sine, we only said that we wanted sine from negative pi over 2 to pi over 2. 3 pi over 4 goes way past the restriction, so we can't just cancel these guys out. So what would we do instead? Well, sine of 3 pi over 4, let's try to think about what that looks like. So sine inverse. So sine of 3 pi over 4, so if you remember your unit circle, so 3 pi over 4 is going to be over here. Here's pi over 4, pi over 2, 3 pi over 4. And at this point, it's square root of 2 over 2 with a negative, square root of 2 over 2. And then, so the sine here will be the square root of 2 over 2. And now we got to find the sine inverse of square root of 2 over 2. Remember, sine inverse has a restricted domain, which is just from quadrant 1 and quadrant 4. So we have to take a look at that quadrant, so these guys. So within this range, from negative pi over 2 to pi over 2, what would be my value? So, well, the only value where you have square root of 2 over 2 will just be this one, which in this case would be pi over 4. So you can see why attempting to get rid of the sine and sine inverse would have been a big mistake, because you would have gotten 3 pi over 4, and that's not the answer. It would have actually been pi over 4. Okay. So make sure that you really know this. This is a really important problem. I would not be surprised if I asked you something like this on the exam to explain it. All right, now here we have two other things, cosine, sine inverse of 2 over 3. So here we actually have to do a little bit of work. And so this is how we're going to do it. So we've got to be very strategic about this. So we're going to set this inside part equal to theta. Because this isn't this going to just be an angle, the sine inverse of a number, that's just going to give you the angle. So basically we want to find what is the cosine of theta. All right. So now, so basically rewriting this as cosine of theta will give me the answer. Now we got to think about, okay, well, now I want to make sure that I figure out what theta should be. Well, I set theta equal to sine inverse of 2/3. That's what I set it up as. Okay, I'm going to write sine to both sides, so I can apply a sine. And you can see what happens here is that you'll have sine inverse of theta. Oh, no, that's wrong. You'll have a theta here. And you'll have a sine inverse of 2/3. So that's going to cancel this guy out. Right? Because 2/3 is within the restriction. So you get that sine theta is equal to 2 over 3. Okay. So this guy is just a triangle, right? So if you think of a triangle, right triangle. Here's theta. Sine theta is the opposite over the hypotenuse. So it's going to be the 2 over 3. So how can I figure out the adjacent side? Well, I can just use Pythagorean theorem. So 2 squared plus 3 squared equal, oh, that's wrong. A squared plus 2 squared equals c squared, which is 3 squared. So we got a squared plus 4 equals 9. Subtract the 4 over. Got a squared equals 9 minus 4, which is 5. So a equals square root of 5, because this is a triangle. All right, so this I built based on the sine theta equals 2/3. Now, remember, what we wanted to find was the cosine of sine inverse of 2/3. We said this inside part was just equal to theta. So this guy was just equal to theta. Okay, whoops. It'll let me do it. So this guy right here was equal to theta. So in order for me to figure out what this whole thing is, cosine of sine inverse of whatever, we just need to figure out what cosine of theta is. So let's look at this triangle. Well, the cosine of theta in this case would just be the adjacent over the hypotenuse, which in this case is equal to the square root of 5 over 3. That would be my solution. All right. And now let's take a look at this last example. The cosine of sine inverse of x, with x being greater than 0. So we're going to do kind of what we did before. So notice that this guy is still going to give me a theta value. So we have cosine of theta. All right. And so we just need to figure out what exactly this is. Now I know that theta was equal to sine inverse of x. This is what we kind of set it equal to. So I'm going to attach a sine to both sides. Okay. The sine is going to go away. So we got sine theta is equal to x. All right. So we're going to do the same thing that we did before. Draw a triangle. Here's theta. We know that sine theta is going to be opposite over hypotenuse, so this x over 1, because remember I can write this as over 1. So now let's use the same thing. A squared plus b squared, which is x squared, equals 1 squared. So you got a squared is equal to 1 minus x squared. Take the square root. So a is going to be equal to the positive 1 minus x squared. Okay, since I know that x is positive, right, we're looking at the first quadrant, so this makes sense for this guy to be positive as well. So square root of 1 minus x squared. So all I need to figure out is what exactly cosine is, because cosine of sine inverse of x is just the same thing as the cosine of theta. So that is just going to be the adjacent over the hypotenuse, which is basically square root of 1 minus x squared. And this would be my final answer.